Your calculator refuses to compute 0 divided by 0. Press it and you get an error because there is no answer. But calculus, the subject with the scariest reputation in school, is essentially a machine built to do that division anyway. Legally. Here is the problem that forces it. This curve is y equals x squared, and I want the slope right at this point. Slope means rise over run, but a single point has no rise and no run. So I cheat. I pick a second point nearby, draw the line through both, and measure that slope instead. This line is called a secant line, and its slope is this fraction, how much the function rose, divided by how far I stepped. Call the step size h. For this curve the fraction is simple algebra. F of 1 plus h minus f of 1, all divided by h. Tidy it up, and the whole thing collapses to 2 plus h. Watch what happens as the step h shrinks. Step of 1, slope 3. Step of 0.6, slope 2.6. Step of 0.3, slope 2.3. The second point slides toward the first, the secant line tilts toward something, and the slopes march. 3, 2.6, 2.3, 2.1, 2.01. Every number on that list is honest. Each one is a real division. But the one slope I actually want is at step 0. And at step 0, the fraction reads 0 over 0. The numbers are clearly heading somewhere. The destination is clearly 2. I just have no legal way to say so, yet. And be careful, 2.001 is close to 2, but it is not 2. Closeness is not arrival, no matter how many decimal places I stack. That missing permission slip is what a limit is. Here is the cleanest possible version of the same trap. Take the function f of x equals x squared minus 4, divided by x minus 2. Feed it any number except 2 and it is perfectly happy. At 1.9 it gives 3.9, at 2.1 it gives 4.1. But at exactly 2, top and bottom are both 0. The function is simply not defined there. Its graph is a straight line with a single hole punched in it. Sneak up on the hole with numbers. From the left, 1.9 gives 3.9 and 1.99 gives 3.99. From the right, 2.1 gives 4.1 and 2.01 gives 4.01. Both sides are closing in on the same number, from opposite directions. Now the key sentence, the one worth a margin note. The function has no value at 2, but the journey toward 2 has a destination, and that destination is 4. Getting close to x equals 2 forces the output as close to 4 as you like. Mathematicians write that as the limit as x approaches 2 of this fraction equals 4. Read it exactly like that. It is a sentence about the approach, not about arrival. The arrow underlimb is doing the talking. X arrow 2 means x is traveling toward 2. The equation never claims that f of 2 is 4. It claims the journey targets 4. So here is what lim actually means, the definition nobody says out loud. It is not plug in the number. It is a question and a promise. The question, as x gets close to 2, from below, from above, without ever touching it, do the outputs settle toward one single number? If yes, that number is the limit. If the outputs cannot make up their mind, there is no limit. That single word settle carries the whole definition. And settle toward has a precise meaning, which is a kind of contract. You challenge me, get the output within 1/10 of 4. I answer, done. I just keep x within a small enough distance of 2. You tighten, within 1/1000th. I deliver again with a smaller distance. If I can win that game no matter how demanding you get, that, and nothing less, is what the limit equals 4 claims. In college, this contract gets written with Greek letters, epsilon and delta, and it looks terrifying. It is exactly this game, written in shorthand. Nothing more is hiding in there. Now the traps, because this is where exams draw blood. Trap 1, the limit exists does not mean the function is defined there. Our hold function has no value at 2, and a limit of 4 at 2. Both statements are true at the same time, and exam questions love to make you say so. Trap 2, the reverse. A function can be defined at a point and still have the wrong value sitting there. Move the point, define f of 2 to be 7. The limit is still 4. The approach does not care where the arrival got glued. Trap 3. The two sides must agree. The classic example is x divided by the absolute value of x to the right of 0, it equals +1. To the left of 0, it equals -1. So as x approaches 0, the left side reports -1, the right side reports +1, and the two-sided limit does not exist. That is the honest verdict for a jump. And right does not exist with pride. On an exam, it is often the correct answer. Approach, both sides, one destination. Check those three things and limit questions stop being scary. Back to the slope, because now we own it. The secant slopes were 3, 2.6, 2.3. A journey with an obvious destination and an illegal final step. With a limit, the step is legal. The slope at the point is the limit of the secant slopes as the step h approaches 0. For y equals x squared at this point, that limit is exactly 2, not approximately 2, exactly 2. 0 over 0 was never an answer. It was a question, and the limit is how mathematics answers it. And here is the exam move you will use 100 times. When plugging in gives 0 over 0, do not panic, and do not write 0 out of habit. Factor, cancel the guilty piece, and take the limit of what is left. That is how our hold function gave 4, and how the secant slopes gave 2. One last thing. A slope born this way, a limit of secant slopes, turns out to be the single most important idea in calculus, and it has its own name and its own notation. That is the next video.